Good morning, everybody. Here we are. My name is Carl Rundy, and this is the Physical Science 168 lecture. Physical Science 168, Energy and the Environment, and video lecture 1. Yes, and my name is Carl Rundy. Welcome to this lecture. I haven't taught this one as a video lecture before, but we got a good amount of practice last semester, and the whole thing's going to work out great. So I'll start with our syllabus. I sent out the syllabus, so everybody should have received it by email, and I have it in front of me. You'll notice I kept the thing very minimalist. Everything you need to know is on this first page. The second page is some formalities. So everything you need to know is on the first page. We'll go through it briefly, and then we'll even get started on some material. Okay, it'll still be a short lecture. I'm thinking maybe 15-20 minutes this morning. Okay, so Physical Science 168, Energy and the Environment. This is a upper division science class. I'm a physicist, and I'm going to teach, 2 semesters worth of energy physics in one semester. Is that possible? It's possible. It's going to be great. So let's go through this here. You're not going to visit my office, but the email is going to be very important. So we're going to have email office hours for starters. I have not yet opened up Canvas and Zoom, so until further notice, everything we do is via my email account and my YouTube channel. Okay, I'll be posting lectures 3 days a week. I anticipate always having them there before the formal lecture time, which is 11 to 12. And Monday, Wednesday, Friday. So I'll be posting the videos to YouTube. We'll be communicating via email, and then as the semester develops, we'll see about any other technologies. I'd rather keep it simple, and this is pretty simple. The most important thing I have to announce today is under homework here. It says pictures of your handwritten lecture notes and homework problems and printouts from online sources and home projects must be sent to me by email every Friday. So once a week, you will lay out everything that you have, take pictures of it, and send me a big email. I've done this last semester and it worked out fantastic. In particular, the lecture notes. So you want to take good lecture notes, handwritten. If you use an iPad and make handwritten notes, you can send me that file. That works very, very well. I've seen some beautiful lecture notes using the iPad. Okay, but yes, handwritten lecture notes are very important because what we're doing in this class, we're compiling a book. Okay, there are no textbooks in this course, no required books at all. So the book will be your lecture notes at the end of the semester. So you get the handwritten lecture notes, so that's everything I write on the board, but it goes far beyond that because I'll give you ideas of things I'd like for you to print out, because your book isn't just going to have lecture notes, it's going to have pictures, and you need to have access to a printer so you can print out various and assorted images from the internet. And I'll tell you what I want you to print out as we go through. So that's what I mean by printouts. Homework problems, of course, you just include. I'll tend to solve the homework problems later on, especially if you have any questions about anything I ask for as a homework problem. And you can let me know, and I'll do it on the board right here for you. It'll be part of your notes. In fact, that's how your homework will be corrected. I'm just going to check off that you did it. Okay, if you want to correct it, then you get in touch with me and I put it up on the board and you can go back to what you did. Okay, so that's really the most important thing that's going on this semester is the compilation of this book starting with your lecture notes. All the notes that I put up on the board, you want to take down, make them even nicer, because you can space them out much better than I can on the board here. You can space them out, leave room for additions, leave room for questions, leave room for comments. Okay. Good. What else? Yes. So when you email this homework, which will be once a week, what you want to do is always open up a new message. To my email account, KRUNDE at csufresno.edu. Okay, so that's the new message. And then for the subject, is that what I said right here? Yes, for the subject, because I'm going to be receiving enormous numbers of emails. So for the subject, how did we want to have that? So your name in the subject line, your name, and then, what did I say? We'll say psci 168 homework. So you put this in the subject line, and then when I can open this up on my computer, I have a quick look at it and I check you off in a list that says that you did it. Any grading of that, so whether I check it off or I give it 1 or 2 points or something, haven't yet decided. So you just want to get it in to the best of your ability. I'm going to check it off. In principle, I just want to see that you did it and that you tried to do it and you did a good job. Like I said before, the right answer to a particular homework problem I'm not so interested in, because I can get back to you and you can go back to your notes and make the correction. Okay. That's really all we need to know. Everything else is just details. There will be a midterm final exam. I have 30 students in this class. This can all be dealt with. Yeah, so Friday, no later than 6 p.m., you send this in, and then I'll check it all off. Good. YouTube videos, lecture notes, email them to me. Email office hours. Yeah, when you email me for office hours, probably a good idea to do this as well, just so it doesn't get lost. If I don't respond to an email, just try again. I'm going to be there responding to everything. Good. So there's the formalities. This one page has everything. I deliberately didn't put in a giant schedule of topics because we're going to be doing so much. Let me now give an outline of these things. So energy and the environment. Now, when I started teaching energy type of classes to the general public years ago, I discovered that you can't just do it right if you just do a little bit of physics and then a lot of blah, blah. Okay, so we're doing it the other way around. We're doing a lot of physics, and then knowing the physics, every energy topic in the world turns out to be very basic. Okay, so it's really a physics class. As far as the amount of math you need, the next thing I want to say is do not worry about anything right now. We're in the class, and I've done this before, and I'm going to get you through it very interesting manner. Okay, so let's just do an outline talking about energy. We could call this class Energy and Civilization if we wanted to, okay? So the energy class, in order to teach you the required physics, I have to go back to the very beginning of scientific reasoning, and I'm going to build up the subject of physics for you. You can't find this anywhere else. So we won't actually even get to energy per se until a few lectures from now. And then we'll work our way systematically. Here's what we're going to do. We're going to talk briefly about scientific reasoning. And out of a concrete question, for example, how many days are there in the year? What kind of a question is that? Okay. Out of a concrete question like that, we're going to develop the need for geometry and arithmetic. Okay. So let me go ahead and write that down. I want to give you guys something that you can write down because you're going to turn in these notes on Friday, right? So, how many days in the year? Well, what kind of question is that? Well, try to figure it out on your own. Okay. So I'll give a little discussion of that. And we're going to find that we need geometry and arithmetic. In fact, we even need some astronomy. In fact, why do we need astronomy? Well, we now know, the ancients didn't know, or the ancient ancients. We now know that the Earth orbits the sun and it takes 365 days to do that. Okay. Well, that's an astronomical question. So astronomy. So we'll get into a little bit of astronomy. You can see what we're doing here is we're actually developing the knowledge, scientific knowledge of our Earth and surroundings. Okay. So far, so good. But it's still a ways to go to get to energy. Okay, so we have this block of topics. Then we're going to talk about weight, as in when you lift something, yourself included, and that's an example of a force. So now force, that's a concept from physics. Okay. About weight and force. And with this, we will go to balance, the balance, and the lever, and structures. And this is also sort of a historical development. The discussion here is actually going to be from 2,000 years ago or longer. And the structures were also built by early civilizations. So that's going to be another block. And finally, we will talk about force, work, and energy. So that's what's going to take to actually even get to these concepts. And right now I don't have any pretty pictures for you. You guys are going to supply the pictures because all of these topics will involve some interesting downloads that you can print out. I'll be doing mathematics here. Here we'll have some interesting structures. What am I talking about structures? I'm talking about buildings, bridges, dams, aqueducts, all manner of interesting structures that we will understand because we know what forces are, and we'll know what forces are because we understand geometry. Okay, so in that sense, we're building this whole subject, and this is just at the very beginning. No pictures yet. So let's see if we can, I'm not going to put the whole outline on here by any means, but this will already be quite a bit because we'll finally know what we're talking about. Okay. Let's go ahead. I like numbering things, okay? That's not going to be enough. We're going to have to study the science of motion. Okay. Motion and free fall And you know what, I'll finish this list right here with my 10th point. We will end the topic on motion and free fall with satellite orbits. And I'll already tell you what one of our exam problems is going to be for you guys to calculate the speed of an orbiting satellite. Okay, right now you'd say, wait a minute, did I sign up for satellite orbits? But yes, we will actually be able to do these things. We'll use some laws here, some geometrical laws there, and before you know it, you know how to do that. Okay, let me send this list up, and this short introductory lecture, I want to end with just another reminder that it's all about the video lectures, the notes, okay? Do not ever get discouraged if you think I'm doing something too complicated. Just write it down, construct it, and at the end of the semester there's going to be a book with a logical development that I'm responsible for. So the big picture will become clear. I'm responsible for that. You will also develop all manner of skills on the way through here, and you'll know about energy the way fewer than 1% of the people in the world know. Okay, we're definitely going to learn a ton this semester. I'm looking forward to it. So this is the end of the first lecture. It already gives you something to send in. On Friday, I'll launch into some of these topics and you'll have more. So Friday afternoon by 6 o'clock, you'll have whatever we talked about today, whatever we talk about on Friday, to turn into me as an email, as an image, picture that you took. You will send it to this email address with this subject line. The picture that you take, I just want to make sure I can see very clearly. I did this last semester. They tend to be quite legible. See clearly what you did. There's one thing I didn't mention yet that I should right now. So materials, you want a 3-ring notebook about 1 inch thick or more, and that will be the thing that holds your entire book at the end of the semester. So just a 3-ring binder and paper. You have access to a color printer. That I'd say that's pretty important. You have access to it at least once a week. You print things out and show me everything that you did. That's going to be the thing. Last semester I taught a different class called Energy, Technology, Society. It was very, very similar to this. And some of my students, they got so into it, they did some little demos. You know, I would do a demo here on the table and then go do it at home and take a little video of it, and they included the video clip in their email. So many things are possible. It's going to be great. Okay, let me close by wishing you all a successful semester in all of your classes, and I'm looking forward to all of this work. Okay, see you next time.